All right. Welcome. Thanks for coming to another workshop here. Um, this is going to be we'll talk about Paladin, and that's a technology that we are hoping will bring privacy on top of EVM. Just a little agenda here. I'm going to go through a little bit of an introduction about who we are and what Paladin is, and then talk about how the project works, what its goals are, how you can get involved in it, and then show a demonstration of what it can enable in terms of actual privacy-enabled workflows running on top of an Ethereum network. Myself, I'm Andrew Richardson. I'm a principal engineer at Kaleido. I'm focused in the area of digital assets. So I actually work with a lot of institutional finance, like banks and that sort of thing, talking about how to find the intersection of enterprise and traditional finance with Web3. This is Trevor Scanlon, who's part of our technical enablement team, just kind of works with everyone across the board, whoever needs help getting a blockchain solution. Our company, Kaleido, if you're not familiar, our mission has been very enterprise focused. We came out of the enterprise world, all of us, and saw the opportunity for helping enterprises find a way to make blockchain work for them, whether it's digital assets or anything else, but make it very, very simple to both build and scale critically, right? Because enterprises are always very concerned about, if I get a proof of concept, how do I go from like a proof of concept to something that I could scale to actual millions of transactions and users? So that's kind of our specialty, is helping run all the infrastructure needed for that, and then also helping develop use cases and build things that you can really actually deploy and scale. We offer a variety of services and software stack, starting with like the chain infrastructure, right? We run nodes for various different chains. We run Web3 middleware. There was a workshop earlier on Hyperledger Firefly, which is our open source middleware that is part of the Linux Foundation Decentralized Trust. And then we have, digital assets and custody solutions and that sort of thing on top of that. And then here we love open source. We love to be part of open source. And so a lot of our workshops this weekend, we're focusing on open source projects because we'd love, for the Web3 community to be more involved in these projects, including Hyperledger Firefly and including the subject of this workshop, Paladin, which has just been released within the past year as a lab in the Linux Foundation Decentralized Trust. So what is Paladin and why is Paladin a thing? The short answer is because we believe EVM is an important ecosystem. I know at a conference like this, there's so many different chains and different ecosystems, and they all have their various benefits. But EVM as a tech and then Ethereum as a chain, it is an ecosystem that just has a lot of activity and has a lot of really established weight. So, whether it's Ethereum mainnets or L2s or just other chains that have EVM compatibility, right? EVM has become this sort of common denominator for a lot of the chains where assets are, frankly, where things are currently. So it's one of the largest ecosystems out there. But the thing with EVM is that there's not been a single privacy solution that really solves all the problems of privacy, especially when you're talking about institutional solutions where you might be dealing with very private and sensitive data. So it's been a real barrier, and we've seen lots of projects fail or move away from Ethereum and EVM-based ecosystems because of the lack of a unified privacy solution. There have been very sort of individual solutions that attempt to tackle one aspect of privacy. Like I made this token or this zero knowledge proof or this smart contract that solves a piece of the puzzle. And there have been so many piecemeal bits, but nothing really truly unified. And so we saw an opportunity. We said, I think there is a hole here that needs to be filled by something open source the community can get behind and really make a pluggable platform for whatever your privacy solution is, bringing that to EVM and running it on top. So that's what Paladin is. Paladin is a programmable and pluggable ecosystem for privacy. It is a single runtime that runs next to an EVM compatible node, any EVM compatible node. So it's critical choice that we made in this project is that you don't have to modify the node. There have been previous generations of privacy tech on EVM networks where you had to run special code, right? You had to tell the node which things were private and not. And we just saw a lot of problems with adoption of that because you can't connect it to existing chains, right? It's very difficult to integrate those. So Paladin runs next to an unmodified EVM, any EVM-based network. And Paladin, it's a separate runtime. It has a lot of things kind of in the bottom two rows here of the picture that are just sort of the table stakes for blockchain, right? It has APIs for connecting with your smart contracts, for storing private data that's related to those contracts, because that's the only way to do privacy is I have my smart contracts and I have separate storage for private data. It helps you manage keys and plug into different signing solutions. It helps you orchestrate transactions. This is actually a huge bit of it. There's some overlap with the Firefly project and other things that Kaleido's been involved in over the years. But transaction orchestration is a huge part of working with any blockchain ecosystem, just efficiently getting things onto the chain. On the reverse side, indexing and event streams, getting things off the chain, figuring out what matters to me. And then on the right, some very privacy-focused things. So it has ZKP proof engines by running WASM code and supporting things like Circum to run zero-knowledge proofs, as well as encrypted private data transfer between Paladin nodes. So it's a sort of a runtime that goes next to your node, and you could have many Paladin nodes connected to a single EVM blockchain node. But it provides all these additional services. Some of them you can see are just sort of general purpose, and some are very privacy focused. So it's designed to be this suite of additional services that you can just have running right next to your node. And then at the very top, my Zoom is hiding it a little bit. At the very top is where I kind of want to spend most of this workshop talking about is these little puzzle pieces that we believe are the real power of what Paladin brings to this EVM space. Is that there is a privacy framework where you can plug in any privacy tech that you would like. And in the box with Paladin so far in the open source, we have three that represent, in our opinion, the three most common privacy patterns, not just in EVM, but in the decentralized ledger space. So the three most common patterns that we've seen. Starting from the right, the first one is private EVMs. So just very straightforward, the ability to run EVM-based logic, right? Smart contracts that represent business logic, but run them in a private way. So run them in a place that is lightweight and doesn't require a separate app chain for every single contract or a separate side chain, but a way to just leverage that power that, we have a lot of people out here that know how to write smart contracts, that know how to write business logic, that see the value in this ecosystem of that type of logic, but don't want to run it on a base ledger, don't want to run it in the open. So that's the first one, is the ability to run private EVM logic. And then on the next two, next to that are both tokens, because tokens are the thing that makes any of this worth it, right? And we've seen two very clear patterns for tokens. The first we call issuer-backed tokens. Sometimes they're called notarized tokens, but these are tokens that have a central party that is kind of responsible for them. It might be a sort of regulated financial instrument that has a custodian that is legally responsible for knowing what's going on. Or it might just be a decentralized system where you choose to centralize some portion of control. So there's some element of centralization to these, but we believe they have an important part in the ecosystem. And there's many, many solutions out there that kind of conform to that pattern. So that's one of the patterns. And then there's ZKP tokens, which are, of course, one of the more exciting things in the EVM ecosystem. Tokens that are backed by zero-knowledge proofs, very sophisticated mathematical proofs, so I can prove that I own something or that I did something without disclosing to anyone that shouldn't have the information, the details of that transaction. So I'm going to talk through these in a little bit more detail, these three different privacy frameworks. I'm not going to get into everything else that Paladin is. So I think including this slide, just to kind of say there is a lot going on in Paladin. It is a ton of code that has come out of many years of Kaleido and other communities kind of bring this together. So a lot of code in the open source. Definitely go to the GitHub, find it through Linux Foundation, and look up Paladin. I'll give some links at the end as well. But all of this kind of stuff, the transaction engine that I was talking about for helping you get things on the blockchain, it's not even completely related to privacy. There's elements of it that help you to get privacy-enabled transactions out there, but just That bit of getting things on the blockchain is super useful on its own. Things like the pluggable key management, the private state storage, it's all in there. So this is all out there in the open source, and plenty that you could kind of learn about and contribute. We're definitely looking for other people to get involved. On that topic, I do want to just kind of talk about what I'm running here. So I want to spend a lot of time in this workshop actually just doing a demo and talking through how the demo works, because I think seeing is a lot better than just telling. I am going to have a Paladin setup running on my laptop. It's a very easy local development experience. You don't have to have any cloud services. Of course, if you want to talk to Kaleido, we will be happy to provide you with cloud services and scale you from development to production as quick as you like. But it's very easy to get started purely in the open source community. I'm going to have 3 Bezu nodes that represent an Ethereum private network. They're running on my laptop, and then 3 Paladin nodes connected on top of that. And then I'm actually going to write, I have an application that runs on top of those, a decentralized app. So 3 instances of the application. Actually, I take it back. I have 4. I only showed 3 here, but I'm going to have a 4 node. I needed a 4th. I always need a 4th one, someone that's not involved, so you can see the privacy. So you can get this running on your laptop as well. I'll take a break out of the slides here to just show the docs. If you go to the Paladin GitHub, you can link to the Paladin docs, or paladinprivacy.org is our homepage. So if you go to paladinprivacy.org, it'll give you the link here as well. The installation is super simple. It is a Kubernetes-based installation. So we have a Kubernetes operator that'll install Paladin for you. I'm using Kind on my laptop, which is a great way to just run Kubernetes stuff locally. But I mean, it's literally just a handful of commands you run here, and you will be up and running with the exact same infrastructure, a private blockchain and a private set of Paladin nodes. I think, yeah, let's talk. Maybe before I do the demo, I'll talk just a little bit more about these 3 privacy domains that you're going to see in the demo and how they work. I mentioned all of them, but I think I think I want to set the stage just a little bit more, and then I'll show kind of, I've got a little bit of a marketplace demo that shows how you can do an atomic transaction that uses multiple different privacy technologies all together, settled on a single Ethereum chain. So the first thing I want to talk about is the private EVMs. I'm just going to give kind of a light overview here, but you can get very, very deep on this, and I enjoy doing that. But just at a high level, these private EVMs, they're not full blockchains. They are a domain. They run actually a part of the Bezu code base. We're very, very big proponents of Hyperledger Bezu as a Ethereum node. And so we actually pulled just the EVM module. So it's the thing that runs EVM-based code, doesn't do all the blockchain consensus. But you can set up these privacy groups, and we call this domain Pente. We had to come up with sort of code names for each of these different privacy techs. So our private EVMs are called Pente. It's a play, if you're familiar, there was a very popular privacy tech called Tessera, which means 4, Pente means 5. So this is kind of a successor to some of the privacy-based technologies around EVMs in the past. You have a set of members that set up a privacy group. They say, we want to run EVM logic together, but we want to run it privately. One of them can propose that privacy group, and the others agree to it. And then if I want to deploy a contract into that privacy group, I share the bytecode privately with the other members. We all compute where that bytecode would be deployed. We all share the result, and we all co-sign a single transaction that goes to the base ledger. If I want to then do something on that contract, any member of the privacy group can propose a transaction. They send the inputs privately to the other members of the privacy group. They all run it through their ephemeral EVM, and they compare results, and then they all co-sign a transaction that goes to the base ledger. So there's this pattern of we're all independently executing EVM logic, and we're agreeing on the results through a private communication bus, hashing those results of the inputs and outputs, and then putting them on a base ledger. So every time I do a transaction in the private EVM, it results in a transaction on the base actual, ledger, but it's fully masked. The details of what was executed is not disclosed. It's just kind of the inputs and outputs results. Tokens are very different, and I think this was one of the confusing things about previous generations of privacy tech, is that private EVM logic is very different from tokens, in my opinion, or in our opinion. And so I talked about these 2 different token implementations. The reference implementation of the issuer-backed tokens is called Nodo, and this is where you have a trusted party managing the token. So there is communication back to that trusted party for every transaction. Again, it's not as fully decentralized, but it is a common pattern that we see a need for and that institutions often want. So we support that pattern in the reference implementation of Nodo. And then the zero knowledge private tokens, the reference implementation is called Zito. So you'll see these three kind of code names pop up in the demo for the different tokens that we're using. And the Zito tokens, they can be transferred around without any involvement of a third party. Only the two transacting parties know what's happening, and they know that they can trust it because of the zero knowledge proofs. They both verify the zero knowledge proofs, and then they can verify that the transaction was valid. And again, the real interesting thing about Paladin is that you can take all three of these things. You can take private EVMs, you can take notarized tokens, you can take zero knowledge proof-backed tokens, and you can take anything on a base EVM ledger. You can roll them all together. You can do them atomically, you can mix and match them. And that's the thing that has been missing, right? You'll in many other sort of privacy scenarios, it feels like you need to pick one, and that one is the thing that's going to solve everything. We believe it's never just one. It's pick all of them, use whichever tech or whichever pattern makes the most sense for each piece of my solution. All right, so that was enough talking. I do want to show demos, and I want to talk through demos because I think it's really interesting to see in action. So what I've got here is I've built this application. It's 2025, so heavily vibe coded, but you too can run Paladin on your laptop and make a privacy-enabled application that transfers assets around in a privacy-preserving manner. I've represented a marketplace here. So this would be sort of assets that are going to just be represented by ERC20s, you know, sort of like you would see on any exchange out there. I am just for now, I am storing them on the same private Bezu network that I'm running, but I've constructed this demo so that they could be anywhere. They don't have to be on the same network. The way we're going to settle this transaction, the assets could be out on, you know, mainnet or on an L2. They could be on a different exchange. So we're going to kind of treat them that way. I've got, you know, representing, you know, maybe these are tokenized real world assets. Just kind of threw some things in here to say, okay, we're going to build a marketplace. But the difference here is that I'm not going to directly settle these in the open. I don't want to disclose the details of my payment. I actually want to settle using some traditional sort of finance rails. And this is where the topic of this particular workshop comes in, because we're talking about the intersection of DeFi and traditional finance and thinking about, you know, when I'm not willing to be completely anonymous or not able to be in a completely anonymous place, how can I bring both, you know, a trusted institution to help me settle something, but also transact in a public network in a way that preserves my privacy and doesn't disclose what I'm doing with these different parties. So I have a couple of banks represented on this network. So this is just my bank one, and this is my bank two. In this example, bank one is actually issuing these assets. So they're issuing assets as ERC20s backed by actual things that they hold, and they're issuing them into a public network where everyone can see the assets. But the payment is going to be handled privately. So I've represented two tokens in this network. I've represented a CBDC or stablecoin, some sort of universal token that can be used for settlement. And then I've represented that each of these banks is also issuing their own tokenized deposits. So we definitely see a world coming where commercial banks issue money in the form of their own tokens, right? There's a lot of interest in the parties that I talk to on a regular basis in terms of creating digital money that is backed by a single bank. So what we're going to represent here is a multilateral privacy-enabled transaction where one user at bank one or a user, I think they're at bank two, they want to purchase one of these assets on the marketplace. And we are going to say that they want to pay with bank two money. So they want to pay with money that they've deposited at their bank, right? They don't want to convert to some other crypto. They want it all to be handled for them. So they're going to say, I have, you know, $1,000 deposited at my bank. I want to buy this digital asset. Can you handle all of the intermediate transactions in a privacy-preserving manner to make that exchange happen and make sure it's atomic and fully protected by all the parties involved? And of course, there's going to be multiple parties involved here. Actually, I have a picture that I should be showing as I talk to this. There are going to be multiple parties involved because there is the bank that's selling the asset, There is the bank that's providing the tokenized money that the user is using to buy the asset, and then there's the user themselves. So there's actually a two-step settlement for the money. The user is going to pay their bank, and their bank is going to pay the selling bank. So there's one tokenized deposit where the user pays their bank, then that bank is going to use, I've represented it as a CBDC, but it could easily be a stable coin or other sort of settlement rail that's accepted by the two banks, whatever those two banks choose to accept between them. And they can be different tokens. And then also there's the asset moving. So we're going to move three different things. We're going to move them atomically and such that no one can back out and not fulfill their end of the deal. Well, you're going to see the involvement of these various Paladin technologies. You're going to see at the very bottom, the base EVM. Everything rolls up to the base EVM. Everything's always going to be protected by transactions on this Bezu Ethereum network. But we're going to actually start up high in a privacy group. So we're going to kick off this process by a user saying to the marketplace operator, I want to buy this asset, right? The operator here is facilitating an application where users can come in, they can buy something, and then they tell the operator, I'd like to settle my payment, go talk to my bank and work out a way so that I can pay via my bank. That privacy group is going to be initiated by the user coming into this operator app. And they're going to deploy a private smart contract that involves the market operator and the buyer bank and the seller bank so they can all get together and agree on a route for this payment to happen. The buyer's payment and the settlement payment between the banks is going to be negotiated in this privacy group, so it can't be seen outside. And then the result is going to be rolled up. It's going to create this other contract that I call Atom, which is basically an atomic settlement contract on the base ledger. And then all of the parties involved will delegate their authority of their tokens to that Atom contract. So the seller that the buyer that is paying in their tokenized deposit, they delegate control over some amount of their money, their bank money, to this atomic swap contract. The buyer bank, who's going to pay the seller bank in another coin, they delegate control of some of their tokens to this atomic swap. We all agree that that thing is going to be the settlement, and it's got an expiration time and it's, settled. As long as we all do our part, it's going to settle and it's not going to roll back. But if anyone doesn't do their part, it expires and the deal is off, right? So that's the power of atomic settlement on an Ethereum chain. And then separately, there's an asset token, because like I said at the beginning of this, the asset token might be on a different chain. We see this very often that, maybe financial institutions are going to be transacting somewhere and assets are in a completely different place. So what we're going to do is we're actually going to lock up all the payments, delegate them to this Atom. Then while they're locked up, and only while they're locked up, the asset can move on the other chain. So the asset will move to the buyer. And then once that happens, we can then unlock and the money will move. All right. So I'm going to do this and then we can talk about it because it'll actually happen kind of quickly. I will just show you here this. So bank one is the one that is selling these assets. So they've put these assets out there on the marketplace. Bank two is the one that is going to be hosting. I got logged out. Bank two is hosting the buyer that wants to buy these assets. So they've issued some tokenized deposits. So this is bank money that's given just to their bank clients. And then I have in a separate window here. Nope, that's Zoom. I have over here my user. And so my user has an interface. This user. Come on. Okay, so this is the user's interface to their bank. They can see how much money they've deposited. So this is, think of it like my checking account. Let's try this one. They need to see the marketplace as well. Okay, well, let me stop share and see why my marketplace is not, because I need that to work. Okay, well, my environment went to sleep. So, okay, yeah, I will come back. So I'm going to talk for a second while my environment wakes up. That would be what happens, but I am using here some of the Collective services to provide indexing and asset management, and they all went to sleep while I was doing other things.
Cost savings.
Yeah. So let's see if this can come back up. Um, I could talk here a little bit about while I'm in my editor about the smart contracts involved. So I've showed a diagram of what this looks like, but I just highlighting again that what I'm running in a private EVM is just a normal smart contract, right? The really key part of the sort of Paladin mission here is that you don't have to write things in a different language. If you're in this Ethereum ecosystem, this EVM ecosystem, you write with the same tools that you already know. And if you've developed a token that could go out onto a current network, you can reuse 90% of that logic to write a privacy-enabled contract. And that's a really powerful thing we found for a lot of people because they've invested in this method of thinking, in this method of programming. So I have here this asset payment contract that is it's a state machine like many contracts are. So I prepare my various payments that need to go into it, and then I settle and export it, once it's fully ready to execute as an atomic swap. All right, let's see if my services are back up. There they are. Okay, so now I'm back up and running. I am a user. I'm logged into this marketplace that's provided by this marketplace operator. I can see the assets are out there and who's offered them. So, one of these banks has offered some assets for sale. These assets, again, could be on any chain, could be any token that's out there on Ethereum today. I say, okay, I want to purchase some of this index fund. So I'm going to say, two units of this index fund. And I'm going to choose, this is the interesting thing again here, the intersection of DeFi and traditional finance. I don't have tokens. I want to pay with just my bank money, but make it happen. Give me a digital asset using my bank money. And so maybe I have a debit card that I've enrolled and they know how to contact the bank that issued that debit card. So I confirm. And from here, this application is actually kind of on autopilot. So it's going to do a lot of transactions. Then we're going to talk through what it's doing because all of these transactions are actually privacy enabled transactions. But it's responding and talking back and forth. These are fully separate instances of the application. So what happened here is that the operator requested, or the user requested to purchase this asset. The operator contacts their bank and says, your client would like to purchase something. Can you set up a payment route to route money from that user to this other bank? And then both banks get involved and they come into the privacy group and they agree. And then all the payment details get prepared. The payments get locked. The payments get delegated to the base contract on the base ledger, and then they get unlocked, the asset moves, and then the payment moves. So a lot of things just happen. We're going to talk through every step individually, one by one, and look at the privacy characteristics. So starting here in block 1334 and 1335, this is where we actually begin with that private contract. So I'm going to look here at the Paladin block explorer. This is a bit like a traditional block explorer, except that Paladin is enhancing the data with any private data that it's also received. Because again, what Paladin provides next to your blockchain is also a private storage where each Paladin node can communicate point to point with other Paladin nodes and share extra context about a transaction. This is how almost every privacy tech on top of a blockchain works, is that you put some of the data on the ledger and then you privately share some additional context. So here we have in 1334, I am looking at a node, of course, that is the one for the operator. So they're the one that actually the user went to them and initiated the transaction here. This is hard to see. So this was in the Pente domain. Pente, again, is that private EVM. So I am deploying, I call deploy. I'm deploying a private contract into this privacy group. I set what are the members that are going to be able to see this privacy group. Or sorry, this is actually creating the privacy group, not deploying the contract. I'm actually deploying the privacy group itself. I think, no, this is creating the contract. Sorry. This is creating the contract. So I say what members are going to be able to see this contract in this privacy group. And then I specify the inputs of that contract I was just showing you, right? That contract, that's a state machine for the sale. I specify, who's the buyer bank, who's the buyer, when does this sale expire, who's going to be the seller bank that provided the asset, what token do I want to use to settle between the banks, right? I propose, this is all a proposal for everyone to agree to. And the really interesting thing is, so I can see all of that. If I go over here to bank one, who's the selling bank, they can also see it. So they look at the EVM private transaction and they can see some of the details about what happened. But if I go to a member here that is not involved in the transaction, it's a very different, they have very little data. They have the blockchain receipt, but all they can see is that some states changed. They have hashes of states. Paladin uses a UTXO model. So all three of these domains, Pente and Nodo and Zito, they use an unspent transaction output. So in the case of tokens, it's pretty easy to understand. I have these tokens, they have value attached, they have owners attached. But what I do is I don't put the whole amount and owner on the base ledger. I just hash it and I put a hash of that UTXO on the base ledger. But if you know the data behind that token, you know how much it was worth and who owns it. For Pente, it's actually really interesting. Yeah.
Validation is occurring.
On the base ledger, it's going to be things like double spend protection because every UTXO is unique. And so you're going to know that you can't spend one twice. It also does unique transaction protection for like replay attacks and things like that. Every transaction needs to have a unique ID. And it ensures that I won't accidentally double execute a transaction or that someone can't take one that they saw and run it again. So it provides some of the really critical protections to ensure that everything is spent once and is spent in a valid way.
There's like a UTXO graph on the base ledger.
Yeah, exactly. So what we actually have, there's this layered thing, and if I go maybe back to the diagram here, what's on these at this base ledger is a UTXO graph. And then up here, it looks more like an account-based token. So it feels, so I call things, I call into this layer, into the Paladin layer, and say, mint 1,000, transfer 1,000 from A to B. I treat it like an account-based token, but the way it's actually represented on the base ledger is a UTXO. And Paladin's providing that translation layer. So doing UTXO on top of Ethereum, but making it still feel like Ethereum. And so what I was saying with Pente as well, even though Pente is actually private EVM execution, all we do is we take the output account states, so a blockchain or an EVM, it's just a set of states, right? It's contract addresses, they have storage, they have accounts that go up and down, right? They're storing balances, all of that stuff. It's just states. And so we take those states and we treat them as UTXOs. So every time I run a private EVM transaction, the states that result in that are getting hashed and stored as UTXOs. So my blockchain world state is also represented as a UTXO graph on the base ledger of just spent and unspent outputs. And that way I can't, if I run a transaction that changes a contract, I can't then run another transaction that tries to use the same starting state because blockchain is world state. My world has moved forward, that private EVM has changed state. So it maintains the ordering and ensures that all the members of the privacy group know what the state of that private world is. And then you have here, I guess the point I was trying to get up to is that this member who's just some other bank, this is bank 3 or 4, someone that wasn't involved in the transaction, all they see is those hashed states. They know a private EVM is executing somewhere, but they don't know the instructions that went into it or the outputs that came out of it. They just see the hashed UTXOs. So then kind of moving on through these various things, looking more at the tokens as they come into play. So we see there's a lot of blockchain transactions that happen here. Some of these could be sort of parallelized and packed into the same block, but we do them one by one, so it's easy to kind of walk through the flow. So if I look here, maybe, oh, that one's not me, here. Okay, this was another EVM private transaction recording the buyer details. So that's the buyer bank kind of setting their account info. This one I was not involved in. I'm looking for a particular one that I was involved in. Oh, okay, this is the operator. So yeah, so the operator, a bunch of these transactions are actually preparation of the payments. The network operator doesn't need to see the payments. They're just a facilitator here. They are organizing and routing the transaction, but they don't need to see my transactions with my bank, or whoever's providing my funding. So that's an EVM private transaction. So this is looking... Oh, sorry, I got to get the right Paladin. So this is the bank 2 Paladin. So this is assuming that these different organizations can operate Paladin nodes. And this is a way for orgs to transact and hide at a sub-transaction level, hide from each other sensitive data about their clients and their users. Okay, so this is the bank where I'm going to be paying from. So I should see some of these have actual. Yes, this is the one I was looking for. So this is a transaction that the buyer did with their buyer bank, saying that I want to lock up some value and prepare it to be unlocked for this transaction. So again, this bank, because they're the party to this transaction, they can see all the details of the amount being locked and who it's being designated for, right? I'm going to be using this to pay for an asset, or I'm actually, this is the buyer paying into their bank. So I'm going to pay this back to my bank, and then they're going to settle with the other selling bank. But so they can see this detail. And it's, if I look at the state receipts, so these are the raw UTXOs that are going on the chain. So for instance, these are the UTXOs that would be involved that I'm proposing to use for this transaction. So, 1,000 would come out of this and would be then owned by the bank wallet, right? So I'm proposing a transaction with the bank, but other people like the network operator, they just see, make sure I go to the same block. What transaction hash is this? This is block number 1337. So if I go over here, the network operator, they don't know the details about the payment, right? They just see, okay, it's happening. I'm going to trust that it's being negotiated. And then same thing, the seller bank is gonna, or no, the buyer bank is also going to negotiate with the seller bank. They're going to prepare a separate unlock, probably in one of the next blocks. So they're actually, this is an EVM private transaction where they're going to record the payment details. They're going to say, this is how my buyer is going to pay me. Here's another one where they're going to prepare the settlement. So there's a separate token that settles between the banks. So, this one is private between the, this one is using the Zito token. So this is actually a zero knowledge proof backed token. So I'm mixing and matching, representing that maybe the buyer and their bank are using a notarized token. So that bank fully controls that token. They have to sign off on everything that happens to that token because they want to really tightly control it. But then the settlement method between the banks is a more decentralized zero knowledge proof backed token. And so bank 2 is going to pay bank 1 using this Zito token that's zero knowledge proof. And Paladin is helping me to actually generate that proof and verify it and put it on chain. So in this case, there's a lot more happening to your question of what happens at the base ledger with a Zito token or any other zero knowledge proof token that you plugged in here. A lot more happening at the base ledger. It's actually running very sophisticated verification of a zero knowledge proof to say yeah, you're able to transfer this token. I can verify without knowing how much you own. I know you have enough to make this transaction happen. So we're just completely mixing and matching things in this single transaction. And then kind of skipping ahead to the very end here, what happens in this atomic transaction is the real power of using Paladin and using EVM is you can move everything at once, right? You can take and mix and match these privacy solutions. And you see here that I have 3 private Paladin transactions that all funnel down and come to fruition in a single blockchain transaction on the base ledger. So this first one is the Zito. So this is the transfer of that zero knowledge proof backed token from bank to bank. The second one packed in here is the Nodo. And I am looking from, yeah, so this is the Nodo that is the bank, their user paying back to the bank. So 2-legged payment there. And then the third one is a public execution on the base ledger. We're calling an execute method on the base ledger smart contract. So it's actually 3 things that all happen. And I'm guaranteed, even though these tokens use completely different privacy models, they're guaranteed that they both move or neither one moves. So both parties are protected. And then the way I orchestrated this demo I showed you is that we kind of come down here and we lock up all the payments. And then only once the payments are locked, we do the asset transfer. So the asset could be on any chain. So I can use this privacy enabled chain. I can use a different chain. They could be on the same chain. And I can provide fully configurable privacy options and still transact with assets. They may be on an Ethereum chain. They may be on a completely different blockchain tech. And it all kind of works together. So goal here is very, very programmable, very, very customizable privacy options for EVM-based networks. So we're there just about 15, 20 minutes remaining in the time, and I do want to stop and make sure I give some time for questions. I could talk through every bit of this demo at a lot of length, so I'm happy to kind of take some time to dive more into one of the domains or into the execution patterns. But just wanted to give a plug too for the community. The paladinprivacy.org is our homepage for the project, but you can also find us through Kaleido, my company. You can also find us through the next Foundation Decentralized Trust. And you can find us on Discord, talk to us. It's a very, open community. We're trying to get more involvement and get people, if you're interested in this, or if you have another idea for a privacy domain that we don't have, is there some other interesting privacy tech that doesn't match one of these? Like, let's plug it in, that's the goal here. And plenty of other webinars where me and others have kind of talked about various aspects at high levels and at very, very low levels, getting into some of the details. But yeah, with that, any questions or anything you wanted to hear more about?
Is this related to something like midnight? Variable? Is it?
I should confess, I'm not fully up to speed on Midnight in general. The overall goal of Paladin is to not replace any other privacy tech out there, but to provide a way that any privacy tech could interoperate. We are very focused on providing privacy on EVM and preserving sort of the EVM compatible contracts and that type of thing, which I think maybe the differentiator for Paladin. But yeah, I probably can't talk too much. You don't know anything more about Midnight, do you, Mary?
Substrate-based chain, I don't know if it's running EVMs. I assume that they would. I mean,
I should know more. I know people at Midnight, and I just haven't. It's very hard to keep up with all of them.
Yeah.
But yeah, so I'm afraid I can't answer it in great detail. But
So it's Paladin the base that anybody can utilize, and it's just, or is it like its own blockchain?
it's not its own blockchain. Definitely not. It's an open source code base for running next to a blockchain and kind of providing it's an opinionated set of tools that run on top of your blockchain and provide you with the way to plug in any privacy tech and then to do multiple at a time. Again, I keep coming back to that point of so many other solutions require you to pick exactly one way to do privacy. And if you want to use multiple ways, you have to write the orchestration. And Paladin's trying to be more of like an integration where we have this, this is the way an integration module is shaped, and you can plug something in there, and teach Paladin how to talk to it, and then Paladin can help you orchestrate. So that is the goal. But yeah, it's definitely not its own blockchain. It runs on any EVM compatible blockchain.
So you can kind of curious, like what some companies have come to you saying, well, we like the technology of blockchain, but we can't do yada yada yada.
I mean, that's what every company that we talk to says, right? So I mean, Kaleido is in a unique position, especially at a conference like this where it's very sort of Web3 DeFi focused. We do talk to a lot of companies that are a little bit worried about that world, right? They're like, we've got to be there, like we can't be left behind. We got to find a way to make these things work together and give customers the options to interact with DeFi and to have self-custody in these things, but also to provide solutions that interoperate with traditional sort of markets. So they all come to us and say like, we really feel like we need to be plugging into this blockchain world, but we can't just put everything out in the open. We can't be disclosing customers and balances and things like that. And particularly talk to a lot of customers that have regulatory requirements, right? These banks, FIs, nations that they need to know what's going on, right? And they're also interested in blockchain, but they need to kind of know where things are. And it's a reality of how the world's going to be, where there are places where you can transact and be anonymous, but there are places where there is still regulation and they need things, for preserving privacy and being able to kind of track what's going on without disclosing who, every transaction that people are doing. So yeah, it's the conversations that we have a lot, and obviously why we're investing in things like this is how can you have at an organizational level, whether it's banks or private companies, or we work with lots of groups of organizations that they say, we all want to transact together, but we don't want everyone to see what the other one's doing. And so that's where Paladin is. It's definitely focused at sort of an organizational privacy level. So how can you build almost this outer ring, right? I have a blockchain where everything's shared, but can I build this, this other ring where we're selectively sharing and we're doing private things, and we all agree that they're going to be proved on a blockchain, and it gives me that fully decentralized consensus so that we know that everything we do is backed by a transaction on this chain, whether it's a L1, L2, whatever chain we choose. But we also have this layer of we can talk to each other privately and share additional data very selectively and have it all interoperate.
I also, lingering back, I'm one of Andrew's colleagues on the business side, and a couple of enterprise thoughts that are consistent to be more, I guess, specific are how does this help me model different privacy sort of structures across different jurisdictions, right? So that's a big thing that you said is, my banking activities in this jurisdiction are different from this other jurisdiction. I need composable modular privacy that I can adjust and adapt as regulatory requirements across the globe come about. The second thing that I would say that comes up a lot, and the reason that the architect did this way, is that privacy should follow you around chain ecosystems as opposed to being bound to one. I think that's somewhat of the thesis that came into this as well, and that's feedback we get from enterprises. It's really possible. It's Paladin being compatible with any compatible chain can sort of follow you around as a module for privacy, allow you to truly interoperate against ecosystems with consistent API calls, assets, smart contract models, and patterns. You can define and rinse and repeat across different chains because the future is multi-chain. So just a little bit to add on to Andrew.
Yeah, I mean, one of our sort of philosophies at Kaleido and as open source advocates is that you need to make these adaptable layers, right? And so privacy needs to be adaptable. It can't be like, okay, we've solved it, like we're done. That the whole premise of Paladin is that we're not done. Like this is not like we've solved every privacy problem. Let's go. And I feel like many projects, which solve a lot of problems. It's like, okay, we've done it. This is it. Paladin is very much like we've done it today, but our primary goal is making a pluggable layer so that next year when someone comes out with something even better, like you can plug it in and there's this opinionated way, like we were talking about some of the patterns of how do you make it feel account-based, but then translate it to UTXOs. And it doesn't all have to follow that pattern, but when you establish these patterns, it makes it easier to plug in additional tech without having to rewrite the whole stack, from bottom to top every time and like migrate your whole application. If you went all in on one solution for privacy, you saw how I was working in this application where I was working with a zero knowledge proof backed token for one settlement leg with a notarized token for the other settlement leg, and they feel very similar. I'm transferring them around. I'm looking at my balances, that type of thing. But they're backed by completely different privacy tech underneath the hood, and Paladin just kind of abstracts that all away.
Ask the question of like how Bitcoin can be involved. Like I know it's EVM focused, but say if a bank had like wanted to serve Bitcoin customers, how much of a stretch would that be to integrate that into?
Yeah, I mean, one thing about Paladin, it is very EVM focused. So I mean, now like things like you saw in my demo, I tried to make the asset agnostic. So like you can still do multi-chain, you can do hash time locks and things like that across chains. It's just Paladin's not going to help you with the things that aren't EVM. Yeah. Yeah. And the plug for Kaleido is that we run Bitcoin nodes and we run Ethereum nodes. So, like if you come, something that we do is, okay, if you want to be multi-chain, and we did a workshop earlier on Firefly, which is a tool for doing multi-chain. So it's a separate open source project specifically for sort of abstracting the differences between different blockchains. Firefly does not support Bitcoin because Bitcoin it's very different from, so it doesn't quite support that, but we do run Bitcoin nodes. We do support many different protocols. So yeah, you can find that at different layers, but Paladin itself is really just focused on EVM chains because we saw that hole, right? Many other chains, you look at something like Bitcoin or a Cardano that's already UTXO based, it's not the same shape of problem. It's not that there aren't problems, but it's not the same shape of problem. Whereas with EVM, it just felt like, you know, ERC20 is great, but it's never going to be private, right? And so this is actually, you know, it's a novel set of token standards. We're kind of on our way to standardizing these as sort of a side effect of the Paladin project, is like, what do the token standards look like for a privacy preserving token? Because it's not ERC20. We want it to feel similar, but it's something different. So yeah, we're very, very focused on that particular EVM centric ecosystem with this project. But Kaleido as a company, and, you know, us as open source contributors, it's a suite of different things that address different bits of the problem.
Thank you for the presentation.
Yeah, thank you guys for listening.
Yeah, sorry to freak you guys out from the back here. Just ran out.
All right, drop the Zoom.